Hi guys, we are working on using inverse relationships to multiply and divide fractions. So operations have an inverse relationship onto each other. We've talked about inverse relationships before with addition, subtraction, multiplication, and division. So the equations 4 divided by 1/2 equals 8 and 8 times 1/2 equals 4 show the inverse relationship between multiplication and division. We're going to circle the two equations that show an inverse relationship. So the first thing I'm going to look at here is just my symbol. So I have a division, multiplication, multiplication. I know that this is going to be one of mine because I have to have opposite operations, and division and multiplication are opposite. So I have 9 divided by 1/3 equals 27. So I need to make sure that this is making sense, and I can go up here and check to make sure. So if you see here, in the division problem, 8 was my answer. In my multiplication, 8 was my first number there. So I'm going to look, I have 27. Okay, so those are the same. So it could be either based on that. When we look at my fraction, the fraction stayed in the same place. The thing that flipped was my 4 went from my starting number to my answer. So in this case, 9 needs to go from my starting to my answer. So that would be right here. The other reason I know this is because 1/3 is my fraction in both of these. 1/9 was not my fraction up there. So these two are inverse operations. An art teacher has 4 pounds of clay. She gives each student 1/5 pound of clay for a project. There's no clay left over. So how many students are there? We can write an expression that could be used to solve this problem. So what we're doing in this case is I have 4 pounds of clay and 1/5, I'm gonna actually box my each, and I'm gonna circle my 1 pound, or my 4 pounds, and I'm getting 1/5 a pound. Each is my clue. We are giving this out. Whenever we give things out, that is a division problem. So in the model, each rectangle, I have 1, 2, 3, 4, represents my 4 pounds of clay. And to model the expression, I need to divide each rectangle into how many equal parts? Into 5 equal parts. So I'm going to go ahead and do that. 1, 2, 3, 4, 5. 1, 3, 4, 5. 1, 2, 3. I'm trying to get it as close as possible. It's not going to be exactly, but that's okay. So each part now has 5. So this model shows blank fifths in each hole. There's 1, 2, 3, 4, 5 fifths in each hole. I'll move my sheet up a little bit. So there are 4 models, and each model has 5. So 4 times 5 equals 20 fifths in 4 holes. So 4 divided by 1/4 equals 20. And there are 20 students in my class. So I can check my answer to see if it's reasonable by doing 20 times, remember that fraction stays the same, 1/5. And that is going to equal, so in case if we didn't know how to do that, we're doing 20 times 1/5. So I'm going to put 20 over 1. Remember when we multiply, we just multiply straight across. So it's going to be 20 over 5. In order to figure that out and make it the smallest, what I can do is 20 divided by 5, which goes in equally. So that's going to be 4. Is that reasonable? Yes. They are inverses. Okay? Good luck, guys.